Hello guys, in this video we will continue to discuss the role of a microcontroller in an embedded system, and we will also talk about the criteria to select a microcontroller out of various options available. As already we have discussed that the microcontroller is the brain of an embedded system. So let us find it out how it works. First of all, the microcontroller gets the data from the user or the sensors connected with it. Then with those data, it can process. And how the process occurs? That will depend how you have coded your microcontroller. So depending upon the coding, the microcontroller will process its data. After processing the data, it can take the necessary decisions, and obviously the decisions will depend on user's criteria. And after taking the decision, the microcontroller may be able to switch on or switch off different external devices. So let us consider one example, that in a room there is a room temperature sensor, and the microcontroller associated with that sensor can sense the temperature, and if the temperature is more than 40 degrees Celsius, then the microcontroller will switch on the AC. In the same manner, you can set it such that if the temperature is less than 15 degrees Celsius, then it may switch on a heater. We can take an example too of a micro oven where you set the temperature and time. Then the microcontroller processes those input data and keeps your food heating system on for that particular duration with that particular fixed temperature. Additionally, it can display the timer also, which is counting down on its own, right? So guys, now we have understood the importance of the microcontroller in an embedded system. But the point is, in the market, there are lots of microcontrollers available. So how to choose or select the exact microcontroller that will be beneficial for your own application? So for that, first of all, we can think about is the speed of a microcontroller. What you need to find out? You need to find out that what is the maximum speed required by your system. And on basis of that, you can find out a microcontroller which can match that particular speed. So when we talk about the speed of a microcontroller, a very important term is associated with that is MIPS. It is nothing but millions of instructions that one microcontroller can execute per second. Now you may find it out that the speed which you need, you are not getting it from one particular microcontroller. So at that time, what you can do, you can engage parallel processors to achieve that particular high speed. Then the next thing is power consumption of a microcontroller. You need to find out that how much power you will be able to give to your system. Now, there can be different modes of power, like there is a mode of idle mode. When the microcontroller is in idle mode, you can send it to the power is also on idle mode, so that it requires very less power but it remains on, right? Now every time your microcontroller may not be running with the full load. So if it is not running with full load, it may not require the full power. So is there any option to have low power mode? Those kind of things also you may need to check while selecting your microcontroller. Then obviously the physical features, that how much size you will allow your microcontroller to have. What is the temperature range? that your microcontroller needs to withstand, right? Then the next very important part is availability of the software for the microcontroller. As we know, the embedded system is a co-design of hardware and software. So it is very much required that you should give enough support in the software domain also. So you have to check it out if you have the open source availability of resources. Like you may have free libraries, you may have free RTOS. If you get those kind of free access, then obviously it will be much more easier for you to develop the entire system, right? Now, we all know that the microcontroller is having lots of peripherals in the same chip. So one of the most important peripheral is memory. In this memory, we store our code, we store our data. So the first thing comes in our mind that what will be the size of the memory. So while selecting a particular microcontroller, you may need to find it out that if that particular microcontroller is having an internal memory which can support your code, which can support your data in terms of its size, then how much speed you want out of your memory, how much amount would you like to pay for your memory, that will come in the cost part. What will be the data retention capability of your memory, right? So all these things are very much important while you selecting a memory in your microcontroller. Then in terms of power, obviously it will be better if you can find it out which requires less power. Then in terms of interfacing, it should be easy to interface. Then we come down to the ports. If we have the microcontrollers, we need external devices to connect with it. So out of these external devices, few will be input type, few will be output type. What are the input types? The keypad, sensor, switch. The data when coming from the external world to the microcontroller, you need an input port. Then you need the output port. When your microcontroller needs to send the data to the outer world through a display, through a buzzer, then you need output port, right? So how many input devices, how many output devices you need to connect? Depending upon that, you need to find it out that how many input and output ports are available in your system. Then these ports can be either parallel type or it can be serial type. As you can see, for the parallel type, we have the data from D0 to D7, that is 8 bits of data, and all the data can travel at the same time because they are having different pins or different channels associated with them. Whereas for the serial interface data, you cannot have all these 8 bits going at the same time. Rather, it processes 1 bit at a time. So both of them are having their own advantage and disadvantage. Like for parallel communication, as you can easily see, you need 8 cables, but here you need only 1 cable. Okay, obviously this thing will be faster because all the 8 bits are traveling together, but here the communication speed will be much less because only 1 bit is traveling at a time. But you cannot install this parallel interface for longer distance. Why? Because at that time these bits may interfere with each other, whereas the serial interface can be installed for much longer distances. All our telephone lines, cable lines are, the serial type. So when we are talking about these serial ports, we need to find out that how many serial ports we need, how many serial devices we have to connect with this. Will it be full duplex or half duplex type? Now what is the full duplex and half duplex? In case of half duplex, you can see only one node can send the data at a time. But in case of full duplex, both the nodes can send and receive the data at the same time. So while you are selecting the serial ports, you need to find out in your microcontroller that how much maximum speed it can offer. That may be also a limiting factor for selecting your microcontroller, right? Then the next very thing is about your timing and counting. How you are going to handle the timing part. How are you going to count the external events? Those things depends on timers and counters. So you need to find out that how many timers and how many counters you may need for your application, and how would you like to operate them. Will they be hardware driven, or you want to start or stop them by a software approach? So depending upon that, you need to find out a microcontroller which can match the requirement of your timers and counters. Then the next thing comes that the requirement of sensors and transducers. How many sensors you need to connect to your device? Is it sufficient that if you connect only one sensor, that it will sense the temperature only? Or you need two sensors when it will sense the temperature and also the humidity? So how many sensors you want to connect? And depending upon the sensors, the external world is all about analog. So the sensors are mainly analog type, though there can be some digital sensors also. So how would you like to interface your sensor with your microcontroller? Do you need any ADCs? So how many ADCs you need? And if you want to give back the analog signal to the external world after processing inside your microcontroller, then you will have a requirement of digital to analog converter. So how many digital to analog converters you need in your system? Those can also be a limiting factor while you selecting a particular microcontroller. Then something comes, called handling the non-periodic events. Suppose your microcontroller is busy in processing some data. At that time, you have got a very urgent requirement to sound a buzzer. Then what you have to do? You have to interrupt the ongoing process and you have to ask the microcontroller to execute a different job. Means what? You have to interrupt the microcontroller. So how many interrupts are you expecting to have in your system? And if you have more than one interrupts, then what will be the priority of those interrupts? And if you have the interrupts, then what will be the maximum frequency you will allow to interrupt your system? And except interrupt, there can be another thing which is known as polling. Okay, so for these ADCs and this interrupt part, we will be having a dedicated video where you will have much more in-depth understanding on how this interrupt works, what is the interrupt subroutine, what is the fixed priority, and what is the configurable priority. All these kind of things will be discussed over there. But in this video, what we have tried, in this video we have tried to give you a brief idea that what is the role of a microcontroller in an embedded systems, and out of the different options, how will you select your particular microcontroller. So guys, hope you people are liking our video. So stay tuned and like us. Thank you.